Hello, AP Chemistry students, and welcome to your Unit 4 AP Summer Work, and this is Lesson 4, which is going to be all about Lewis structures. So Lewis structures, remember, which subatomic particle is involved in bonding? Electrons only. Don't you like my cute little picture here of the electrons? All right, so let's talk about the geometry of ionic crystals. The geometry of solids is going to be the geometry of ionic... Hello, AP Chemistry students, and welcome to your AP Summer Homework, Unit 4, Lesson 4, which is all about Lewis structures. So remember, Lewis structures are going to be the pictorial representation of these molecules, but there's one subatomic particle that's going to be involved in this bonding. Which subatomic particle is that? That is electrons only. So let's talk about first the geometry of ionic crystals. They're geometric solids, and they're going to be alternating between cations and anions, and they're going to be in repeating patterns. So here on the right, I have a picture of sodium chloride. Notice how the sodium cation is smaller than the chloride anion. We talked about that in a previous video. So notice how these sodiums are only attached to chloride ions, and the chloride ions are all surrounded by sodium ions. That is the way that geometric solids for ionic crystals are going to be. And they are made because, remember, cations and anions are oppositely charged. So because they're oppositely charged, they're going to be attracted to each other. So let's talk about Lewis structures. There are some steps that you need to do when drawing Lewis structures. First, you need to add up all the valence electrons for all elements in the covalent molecule. Then you have to place the least electronegative element in the middle. That's going to be the element that's furthest left on the periodic table, and this element can never be hydrogen. Next, you're going to connect the central atom to the outer elements with bonds. And remember, these bonds are going to take up 2 electrons, so you're going to have to make track and keep track of your valence electron total. Then you're going to subtract 2 electrons from the valence electron for each bond that you drew. And then you're going to draw the remaining electrons to fill each atom's octet. And then you're going to evaluate. This is the key at the end. You're going to make sure each atom should have 8 electrons around it only. Now let's talk about the Vesper, which stands for the valence shell electron pair repulsion. It's a model for covalent bonds, and it's used to show that the lone pairs are going to repel one another and should be placed as far apart as possible. So here's a little chart from Compound Chem, and it shows the shapes of the different molecules and what their bond angles are and a little bit more, but let's go through them. So for covalent geometry, these are going to be your molecular compounds. You have linears, the first one. This molecule is only one plane, so it's flat. It has 2 electron groups around the central atom. And remember, electron groups are pairs of electrons that can either be in bonds or lone pairs. And the atoms are 180 degrees apart. So down at the bottom of this slide, you have 2 pictures to represent what a linear molecule would look like. The next kind of molecule you can have is bent. This molecule is bent at an angle. It has 4 electron groups around the central atom. 2 of these electron groups are going to be bonded, and 2 of these electron groups are going to be in lone pairs. And then your atoms are going to be 109.5 degrees apart, less than 109.5 degrees apart, actually. And then there's 2 pictures at the bottom of this slide that will show you what they are. The next one is trigonopyramidal. This molecule is triangular in shape. It has 4 electron groups around the central atom. 3 of those electron groups are used in bonds. 1 of those is a lone pair. And the atoms, again, are going to be less than 109.5 degrees apart. And then the next one is tetrahedral. This has 4 electron groups around the central atom. The 4 electron groups are all going to be bonded. There's 0 electron groups that are going to be lone pairs, and the atoms are exactly 109.5 degrees apart.